In November 1971, inside a boardroom in Cedar Rapids, Iowa, Arthur A. Collins was forced out of the radio empire he had built from his basement. The man whose transmitters once connected Admiral Byrd's Antarctic expedition to American living rooms was suddenly in exile. The workers who hand-wired the legendary S-line receivers watched their visionary founder depart. The government contracts remained, but the independent soul of the company was gone. Overwhelmed by debt, the manufacturer was about to be swallowed by a massive aerospace conglomerate. The paradox was absolute. Just 2 years earlier, Collins' equipment had flawlessly connected the Apollo 11 crew to Earth, delivering Neil Armstrong's voice to millions. The company had engineered the most reliable communication network in human history, yet it could not balance its own books. But the real story of Collins Radio is not only the story of an engineer losing his factory to corporate debt. It is the story of the uncompromising American pursuit of technical perfection, and what happens when building the best radio receiver in the world simply costs too much to survive. Every week, we tell the stories of American radio empires that shaped how people heard voices, music, and memory, and what happened when the market moved on. Subscribe if that history matters to you. The story begins not with nostalgia, but in a Cedar Rapids basement in 1932. In the winter of 1932, the American radio dial was rapidly transforming from a chaotic experiment into a highly structured national stage. In living rooms across the country, families gathered around massive wooden console radios, listening to the polished programming of the CBS and NBC networks. The reception of these broadcasts felt like magic, but behind the glowing tuning dials and the fabric grills, the physical infrastructure of American radio was still remarkably volatile. If you were a local station engineer, a military pilot, or an amateur radio enthusiast in the early 1930s, you could not simply open a mail-order catalog and buy a perfectly calibrated factory-built transmitter. You often had to build it yourself, sourcing parts from various hardware stores and specialty shops. The results were inconsistent. Frequencies drifted. A transmitter, the equipment that turns audio into a radio signal and sends it out through an antenna, was a temperamental machine that required constant adjustment and babysitting. As American aviation expanded and global communication became a strategic necessity, the market critically lacked a standard of absolute, uncompromising precision. The solution did not come from the massive corporate laboratories of New York or Chicago. It came from a basement in Cedar Rapids, Iowa. Arthur A. Collins was a 23-year-old amateur radio operator who had been fascinated by wireless technology since childhood. Operating under the call sign W0CXX, he spent his nights communicating with other hams across the country. But Collins was unsatisfied with the erratic performance of available equipment. In the spring of 1932, amidst the deepest economic despair of the Great Depression, he began assembling vacuum tube transmitters in his basement. A vacuum tube, a glass electronic device used to control and amplify signals before transistors replaced it, was the fragile heart of early radio, but Collins discovered ways to stabilize the circuitry around it. He did not want to build cheap tabletop radios for the mass consumer market. He wanted to build the most stable, accurately tuned transmitting equipment on the continent. The components were hand-selected, the circuits were meticulously soldered, and the final output was relentlessly tested. In late 1932, Collins placed his first formal advertisements in QST, the leading American magazine for amateur radio operators. He offered custom-built transmitters to a highly technical, demanding audience. The purchase price was steep for a Depression-era economy, but the equipment promised something incredibly rare in the early days of shortwave, a broadcast band that can carry signals over long distances, often across countries and continents. A Collins transmitter stayed exactly on the frequency it was tuned to. It did not drift. It did not waver. The ultimate test of this Midwestern engineering arrived a year later, in 1933, when Admiral Richard E. Byrd prepared for his second major expedition to Antarctica. Byrd needed to maintain reliable, two-way voice contact between his frozen base camp at Little America and the United States. Rather than relying entirely on established giants like RCA or General Electric, the expedition chose equipment designed by the young man in Iowa. It was a pivotal moment in American broadcast history. Deep in the Antarctic winter, Byrd's crew powered up a Collins 20B transmitter. The signal pushed across 10,000 miles of atmospheric interference, reaching receiving stations in the United States. From there, the audio was routed directly into the CBS radio network. Millions of Americans, sitting in their warm living rooms and kitchens, turned the volume control, the knob that changes the loudness of the sound, on their home receivers and heard live, crackling updates from the edge of the world. They were listening to an AM radio signal, amplitude modulation broadcasting, a radio system that changes signal strength to carry sound over long distances, that had been generated by Cedar Rapids engineering. The CBS broadcast proved to the nation and to the federal government that Collins' equipment was not a hobbyist's experiment. It was an industrial-grade lifeline. The Antarctic success instantly transformed the company's trajectory. By 1934, the basement operation had grown too large for a residential neighborhood. The company moved into its first real manufacturing space on First Avenue in Cedar Rapids, hiring local labor and establishing a formal factory floor. The American market responded to this uncompromising reliability. Local police departments, looking to upgrade their dispatch systems, began ordering from Cedar Rapids. Government agencies required the stability that only Collins seemed able to guarantee. Most importantly, the burgeoning American aviation industry took notice. Commercial airlines were transitioning from visual navigation to instrument flying. When a pilot was navigating through heavy fog over the Rocky Mountains, a failed radio receiver, a device that selects a broadcast signal from the air and turns it into sound, could mean a fatal crash. Aviation demanded absolute faith in the communication panel on the dashboard. Collins Radio stepped into this void, supplying the newly formed civil aeronautics authorities with equipment that refused to fail under pressure. The company established a philosophy that would define its entire existence. Performance dictated the design, and the price tag was simply whatever it cost to achieve that performance. This was the genesis of Collins' quality. It was an absolute refusal to cut corners. A tuning capacitor, a component that changes the circuit's tuning so the radio can select one station from many, was machined to tolerances previously reserved for scientific instruments. The chassis was heavy. The wiring was immaculate. In these early years, Collins mastered the most crucial of the American radio market forces, the cost of domestic manufacturing and skilled labor. They proved that if a radio system was essential for survival, the government, the airlines, and the serious amateurs would gladly pay a premium for it. The Cedar Rapids factory became a symbol of American engineering trust. But this identical philosophy, the belief that ultimate quality justified any expense, was also the seed of the company's eventual vulnerability. By the end of World War II, Collins Radio had grown from a basement operation into a massive military contractor. The company had built the heavy transmitters that coordinated American naval fleets and bomber squadrons across the Pacific. But when the war ended, Arthur Collins turned his engineering force back toward his first love, the American amateur radio market. In doing so, he created a receiver architecture that completely changed the expectations of high-end radio operation. In the late 1940s and early 1950s, the American radio spectrum was becoming increasingly crowded. The federal government enforced strict boundaries on where stations could broadcast. For an amateur radio operator, straying outside their assigned frequency meant risking their FCC license, the legal authorization that allows a station to broadcast on a specific frequency under specific rules. The structural problem of the era was that almost all consumer and hobbyist radios drifted. As the glass vacuum tubes heated up, the internal circuitry expanded, causing the radio's receiving frequency to wander. A listener had to keep their hand resting on the tuning dial, the scale or display that shows which station or frequency the radio is tuned to, constantly making tiny, frustrating adjustments just to keep a voice clear. Collins eliminated this problem with a mechanical and electrical masterpiece known as the Permeability-Tuned Oscillator, or PTO. A standard American radio was typically tuned using a tuning capacitor, a component containing interlocking metal plates that changes the circuit's tuning so the radio can select one station from many. But Collins engineers realized that flat metal plates were vulnerable to temperature swings and physical vibration. Instead, the PTO tuned the radio by precisely moving a powdered iron core in and out of a wire coil using a highly machined lead screw. The entire mechanism was sealed in a protective metal can and baked in an industrial oven to ensure it would never shift. When Collins released the 75A1 amateur radio receiver in 1947, the impact on the American electronics market was immediate. The tuning dial was not a vague slide rule display with painted numbers. It was a direct reading circular dial that looked exactly like the instrumentation panel of a commercial aircraft. When an operator turned the heavy, smooth knob, they knew their exact frequency down to the kilocycle. If the dial said 7,105 kilocycles, the radio was listening exactly there. The receiver simply did not drift. This absolute stability became the American radio moat. Other legendary manufacturers, like Hallicrafters in Chicago or National Radio in Massachusetts, built excellent equipment, but they struggled to match the extreme mechanical precision of a Collins PTO. But Arthur Collins was not finished. The true breakthrough, the moment Collins radio became the undisputed king of the American broadcast bench, arrived in 1957 with the introduction of the KWM-1, and shortly after the legendary KWM-2. Before this era, a serious amateur radio station required a separate transmitter to send signals and a completely separate receiver to hear them. They were massive, heavy, heat-generating boxes that consumed entire desks and required complex antenna switching relays. The KWM-1 changed the paradigm. It was the first widely successful commercial transceiver, a revolutionary device that combines both a radio transmitter and a receiver inside a single, relatively compact cabinet, sharing the same tuning circuitry. Furthermore, it utilized single sideband, or SSB, a highly efficient method of transmitting voice signals that uses less spectrum space and concentrates all the transmission power into the audio itself. This allowed an American amateur operator in a suburban garage to slice through heavy atmospheric static and overseas interference with unprecedented clarity. Physically, the Collins KWM-2 and the accompanying S-Line series components were stunning pieces of mid-century industrial design. They did not look like crude, surplus military gear. They were housed in elegant, heavy-duty, ventilated metal cabinets painted in a distinctive textured shade known as St. James Gray. The front panels were brushed aluminum. The main tuning dial was backlit, glowing with a soft, authoritative light in darkened basement ham shacks and radio rooms across the country. Inside the cabinet, the engineering was immaculate. The printed circuit boards carrying electronic components and copper tracks that connect them, were meticulously laid out to prevent interference. The vacuum tubes were heavily shielded. The volume control, the knob or slider that changes the loudness of the sound, turned with a heavy fluid resistance that felt like a bank vault. The American price context for this perfection was staggering. In 1959, a complete Collins S-Line station, including the necessary power supplies, microphones, and an external loudspeaker, the part of a radio that turns the electrical signal into sound, moving through air, could easily cost over $1,500. At the time, an American could buy a brand new Chevrolet Biscayne for slightly over $2,000. The Collins equipment was astronomically expensive. It was an investment. Yet thousands of everyday Americans, military veterans, railroad mechanics, and rural farmers took out bank loans or established installment payment plans just to put the Collins winged emblem on their operating desks. These specialized radios were not sold in standard hardware stores, nor did they appear in general mail-order catalogs like Montgomery Ward. They were distributed exclusively through a tight network of high-end, specialized electronics dealers. A prospective buyer might walk into Harrison Radio on Greenwich Street in New York City or visit Henry Radio in Los Angeles just to see the S-line glowing on a dedicated display shelf. QST magazine, the undisputed Bible of American amateur radio, ran prominent full-page advertisements that felt more like luxury aviation commercials than standard electronics ads. The endorsement of American institutions was absolute. The Strategic Air Command relied on Collins' single sideband equipment to maintain constant, secure contact with nuclear bombers flying global routes over the Arctic. American Airlines equipped its commercial jetliners with Collins communication panels, ensuring pilots could always reach the tower. The Voice of America used massive Collins transmitters to push American broadcast programming across the Iron Curtain. And in local ham radio clubs from suburban Texas to rural Ohio, owning a Collins S-line was the ultimate symbol of technical arrival. If an operator's voice came through the static with perfect, rounded clarity, other listeners on the frequency would often key their microphones and ask, "Are you running Collins?" It was the highest compliment on the American airwaves. The name on the dial was not decoration. It was a promise about reception. By the early 1960s, Collins Radio had achieved a level of dominance that transcended the consumer electronics market. The company was no longer just a trusted name among amateur radio operators in suburban basements. It had become the central nervous system of American aerospace. The physical footprint of the company in Cedar Rapids, Iowa, had exploded into a massive industrial complex, employing thousands of engineers, draftsmen, and assembly workers. Arthur Collins had built an empire on the premise that absolute reliability was worth any price. And during the height of the Cold War and the space race, the United States government agreed entirely. To understand the scale of Collins Radio during this era, one must look at the sky. In the commercial sector, the transition from propeller aircraft to jetliners was rapidly shrinking the country. When American Airlines and Pan American World Airways introduced the Boeing 707 and the Douglas DC-8, these revolutionary jets were packed with Cedar Rapids engineering. Collins supplied the VHF communication radios, very high-frequency transceivers used for short-range, line-of-sight voice contact between pilots and air traffic control, as well as the advanced flight director systems that guided the planes. When an American Airlines pilot navigated a Boeing 707 through a blinding winter storm over the Midwest, the glowing green dials of the Collins communication panel were the only thread connecting that aluminum cylinder to the ground. That was the American radio stake. A failure in reception did not just mean missing a song or a news broadcast, it meant losing a multi-million-dollar aircraft and everyone on board. In the military theater, the stakes were existential. The Strategic Air Command, the branch of the United States Air Force responsible for the nation's nuclear bomber fleet, required an unbreakable communication web. B-52 bombers loitering near the Arctic Circle had to maintain constant, crystal-clear contact with command centers in the United States. They used Collins' single-sideband equipment, operating on shortwave frequencies that could bounce off the ionosphere and reach halfway around the world. The military trusted Collins because the equipment was over-engineered. It could withstand extreme temperature fluctuations, severe vibration, and the intense electrical noise of a military jet. But the ultimate validation of Arthur Collins's obsession with precision occurred beyond the atmosphere. When the National Aeronautics and Space Administration, NASA, began plotting the American trajectory to the moon, they faced a daunting communication challenge. A spacecraft traveling 240,000 miles away needed to send voice audio, biological telemetry, and television signals back to Earth, all while traveling at thousands of miles per hour. NASA contracted Collins Radio to equip the Mercury, Gemini, and Apollo programs. For the Apollo missions, Collins engineers helped develop the Unified S-band system, or USB, a highly advanced radio system that combined voice communication, spacecraft tracking, biological data, and live television feeds into a single, combined radio frequency signal. This allowed the Apollo spacecraft to use smaller, lighter antennas while maintaining constant contact with Earth. To catch these faint signals, Collins also provided critical subsystems for the Deep Space Network, a global network of massive, highly sensitive radio antennas used by NASA to track and communicate with interplanetary spacecraft. On July 20, 1969, this network faced its greatest test. As the lunar module Eagle descended toward the surface of the moon, the communication link was strained to its limits. When the spacecraft finally settled into the lunar dust, Neil Armstrong keyed his microphone. The audio signal, carrying the words, "Houston, Tranquility Base here, the Eagle has landed," was processed by a Collins transmitter inside the lunar module. It traveled through the vacuum of space, was caught by the massive dish antennas of the Deep Space Network, and was instantly routed to Mission Control in Texas. From there, the audio was fed to the broadcast networks, CBS, NBC, and ABC, and beamed into millions of American living rooms, kitchens, and hardware stores. The most famous broadcast in human history, heard by an estimated 600 million people worldwide, relied on equipment designed by the company from Cedar Rapids. At that exact moment, Collins Radio was the undisputed king of American radio engineering. They had effectively built a communication line that stretched from a Midwestern factory floor to the Sea of Tranquility. Yet, ironically, the very era that brought Collins its greatest technical triumphs was also quietly laying the groundwork for its financial ruin. The demand for absolute reliability pushed the physical boundaries of the company far beyond its Iowa origins. By the 1960s, the Cedar Rapids facilities were operating at maximum capacity. To handle the overwhelming influx of military and aerospace contracts, Collins Radio expanded its manufacturing and research footprint, opening massive new complexes in Dallas, Texas, and Newport Beach, California. The company transformed from a regional Midwestern manufacturer into a national defense and electronics titan. At its absolute peak in the late 1960s, Collins Radio employed more than 24,000 workers across its American facilities. The production lines were entirely domestic, utilizing highly skilled, well-paid American labor. Inside the pristine Dallas and Cedar Rapids plants, technicians sat at long, brilliantly lit workbenches, carefully hand-soldering intricate wire harnesses and calibrating printed circuit boards. Every component was tested, retested, and subjected to environmental extremes. Arthur Collins operated the company not as a traditional profit-driven corporation, but as a vast, uncompromising engineering laboratory. If a military specification required a component to survive a 50-degree temperature drop, Collins engineers would design it to survive a 100-degree drop. While the Apollo program and the Strategic Air Command contracts generated the massive revenue, the cultural heart of the company remained firmly rooted in the American amateur radio community. The KWM2 transceiver and the S-line separates were the undisputed royalty of the amateur bands. To understand this cultural peak, one must look inside a typical high-end American ham shack in 1968. In a wood-paneled basement in suburban Chicago, an operator would sit before a heavy wooden desk, illuminated only by the soft glow of the Collins tuning dials. Outside, a massive rotary antenna, a structure that receives or sends radio waves mounted on a tall steel tower, would turn slowly in the night air. When the operator switched the KWM2 from receive to transmit, the heavy internal relays would clack with a satisfying mechanical authority. The glow of the vacuum tubes would pulse slightly in rhythm with their voice. The audio that traveled across the country was legendary for its articulation. It was a status symbol, an engineering marvel, and a daily communication habit, all contained within a St. James gray cabinet. Throughout the 1960s, owning a Collins radio meant you had reached the absolute pinnacle of the hobby. It was the equivalent of parking a Rolls-Royce in a suburban driveway. Enthusiasts eagerly awaited the monthly arrival of QST magazine just to read the latest Collins advertisements, which showcased the equipment as the definitive standard of American communication. Distributors like Amateur Electronic Supply in Milwaukee and Henry Radio in Los Angeles maintained waiting lists for new S-line components. When a used Collins receiver occasionally appeared in the classified section of a radio magazine, it was purchased almost instantly, holding its retail value better than almost any other consumer electronic device on the market. But this uncompromising commitment to engineering perfection was inherently fragile. Collins Radio was operating under the heavy pressure of the first major American radio market force, the escalating cost of domestic manufacturing, components, and labor. Building a radio receiver to military and aerospace standards required an astonishing amount of capital. The research and development budgets at Cedar Rapids and Dallas were astronomical. Arthur Collins fundamentally believed that the market would always pay a premium for the absolute best product available. He refused to compromise on the quality of a tuning dial, the shielding of a circuit, or the thickness of an aluminum chassis. He rejected the concept of value engineering, the practice of reducing manufacturing costs by substituting cheaper materials or simplifying designs. For nearly 3 decades, this philosophy had been entirely correct. The airlines, the military, NASA, and the dedicated amateur operators had willingly paid the Collins premium. But as the 1960s drew to a close, the American economic landscape began to shift. The massive influx of government funding that had sustained the company's vast research laboratories started to slow down. The Apollo program was reaching its conclusion, and the military was beginning to tighten its defense budgets as the political climate changed. Suddenly, the company with the best reception, the most stable transmitters, and the most trusted name in American broadcasting found itself carrying a terrifying amount of corporate debt. The engineering was still flawless. The radios still tuned perfectly, but the balance sheet was collapsing. The decline of Collins Radio was not caused by a failure of engineering. It was caused by the collision of 2 unforgiving American radio market forces: the immense cost of domestic, uncompromising manufacturing, and a sudden, violent shift in national technological priorities. Throughout the 1960s, Arthur Collins operated his company with an unwavering belief that the market would always subsidize perfection. Force 1. The cost of American cabinets, tubes, transistors, components, and highly skilled labor was astronomical at the Cedar Rapids and Dallas plants. But as long as the federal government and commercial airlines were writing the checks, the balance sheet held together. However, by 1969, the environment that had built the Collins empire began to fracture. The American turning point arrived at the intersection of space exploration and the Vietnam War. NASA's Apollo program, which had funneled millions of dollars into Collins' research and development divisions, had achieved its primary goal of landing on the moon. Once the lunar missions became routine and the political will for deep space exploration waned, the massive federal contracts began to dry up. Simultaneously, the United States military was fundamentally changing its procurement strategies. The Cold War doctrine of building heavily armored, ultra-expensive strategic communication systems was giving way to the immediate, Wadain was Nobanwain, tactical realities of the Vietnam conflict. The Department of Defense began demanding value engineering, aggressively seeking out cheaper, good enough systems, rather than paying the premium for Collins' indestructible, gold-plated reliability. Faced with this sudden contraction in government spending, a traditional electronics company would have immediately slashed its research budget, laid off factory workers, and simplified its consumer product lines. Arthur Collins did the exact opposite. He recognized that the future of communication was not just in analog radio waves, it was in computers, digital data, and automated routing. He envisioned a massive, interconnected architecture called the C system, a unified network where radios, teletype machines, and mainframe computers could all talk to each other seamlessly. In essence, Collins was attempting to engineer the foundation of the modern internet a decade before the market was ready for it. To achieve this, he poured tens of millions of borrowed dollars into the Dallas and Cedar Rapids facilities, hiring legions of software engineers, building new clean rooms, and vastly expanding computer research. But the C system was a financial black hole. The development costs were staggering, and the commercial market simply did not understand the need for such a complex, expensive network in 1970. This created an unbearable tension within the company. The beloved amateur radio division, the teams building the legendary S-line receivers and KWM2 transceivers, was still producing the finest equipment in the world. The workers on the line in Iowa took immense pride in their craftsmanship, knowing their units were the most coveted objects in the American hobbyist market. But the amateur radio market, no matter how passionate, was far too small to support the colossal overhead of the entire corporation. Selling a $2,000 radio station to a dedicated hobbyist in Ohio or a doctor in California could not cover the interest payments on the millions borrowed to build computer mainframes in Texas. The corporate debt mounted rapidly. By 1971, Collins Radio was carrying over $100 million in short-term debt, a staggering sum for the era. The American banking syndicates that held the notes grew increasingly anxious. They looked at the Cedar Rapids factory floor, where technicians still spent hours meticulously hand-tuning the permeability-tuned oscillators, refusing to compromise on a single tolerance, and saw a business model completely disconnected from financial reality. The engineering brilliance, that had put American voices on the moon, was now viewed by Wall Street simply as a corporate liability. In November 1971, the inevitable reckoning arrived. Under immense pressure from creditors and a collapsing stock price, the board of directors convened. The investors and bankers had lost faith in the visionary approach. They demanded restructuring, immediate cost-cutting, and strict financial discipline, concepts that were entirely foreign to the company's founder, who still believed that engineering supreme products was the only metric of success. Arthur A. Collins, the man who had built the company from his basement, who had connected Admiral Byrd to CBS radio, and who had wired the Apollo spacecraft, was forced to resign from the presidency of his own empire. His departure sent a shockwave through the American radio community. The amateur operators who had saved for years to buy a Collins receiver understood that the soul of the company had just been evicted. The company was no longer an independent, engineering-driven laboratory. It was a distressed financial asset desperately searching for a lifeline. To survive bankruptcy, the board sought a buyer with pockets deep enough to absorb the massive debt and sustain the vital defense contracts. In 1973, Collins Radio was officially acquired by Rockwell International, a massive American aerospace and manufacturing conglomerate. The Collins name survived on the front plates of the aviation equipment, but it was appended to the corporate giant, becoming Rockwell Collins. The The Cedar Rapids and Dallas facilities remained open. But the culture fundamentally shifted. The new management immediately implemented strict cost controls, streamlined production, and shifted the focus almost entirely toward highly profitable avionics and military contracts. The era of the eccentric, cost-blind American radio genius was over. The Rockwell International acquisition in 1973 saved the physical factories in Cedar Rapids and Dallas, but it fundamentally altered the DNA of the operation. Rockwell was a massive defense and aerospace contractor. They understood government billing, highly classified military specifications, and massive economies of scale. They did not, however, understand the American consumer electronics market, nor did they share Arthur Collins' sentimental attachment to the amateur radio hobbyist. As the 1970s progressed, the American radio landscape was hit by the fifth major market force, a brutal, unforgiving technological shift. The era of the vacuum tube was ending. The market was rapidly pivoting towards solid-state electronics, devices that use small, cool-running semiconductor components like transistors and integrated circuits rather than hot, fragile glass tubes. While Collins had pioneered solid-state technology for space and military applications, transitioning their complex, heavy amateur radios to this new architecture was incredibly expensive. Meanwhile, across the Pacific, a new wave of competitors was mastering this technology at a fraction of the cost. This was the arrival of the fourth American radio market force, competitive displacement by imported good-enough electronics. Japanese manufacturers such as Kenwood, Yaesu, and ICOM began aggressively targeting the American amateur radio market. They flooded mail-order catalogs and local electronics stores with solid-state transceivers that were smaller, lighter, and packed with modern features like digital frequency displays. A Japanese radio might not have been built to withstand the vibration of a B-52 bomber, and its tuning dial might not have possessed the bank vault fluidity of a Collins permeability-tuned oscillator. But an American operator sitting in a climate-controlled den in suburban Ohio did not need military-grade survivability. The imports were more than good enough for civilian use. Most importantly, a complete Japanese station could be purchased for $600 or $700. A comparable Collins station still cost more than a reliable used car. The retail ecosystem adapted to this new reality immediately. Distributors like Amateur Electronics Supply, which had once reserved their prime front window display space for the St. James Gray cabinets of the Collins S-line, began pushing the cheaper, high-turnover imported boxes. The American radio market had fundamentally democratized. The barrier to entry was lower, but the expectation of heirloom-quality craftsmanship was dying. In late 1979, Rockwell Collins made one final monumental attempt to reclaim the American amateur desk. They released the KWM-380. It was an engineering marvel. The KWM-380 was a fully solid-state synthesized transceiver, meaning it used a complex digital electronic circuit to generate a vast range of exact frequencies from a single internal reference, entirely eliminating the old mechanical tuning mechanisms. It required no manual tuning of internal tubes, featured a glowing digital readout, and was built with the same indestructible precision that had defined the company for 40 years. It was designed to prove that Cedar Rapids could still build the finest civilian radio on the planet. Technically, it was a triumph. Commercially, it was a disaster. The primary market force, the immense cost of domestic American manufacturing, remained undefeated. The KWM-380 debuted with a staggering base price of nearly $3,000, which easily pushed past $4,000 once essential accessories and filters were added. In the inflationary economy of the early 1980s, the American hobbyist simply refused to pay a $3,000 premium just to have the Collins winged logo on the front panel, especially when imported rigs sitting on the exact same retail shelf offered similar daily performance for a quarter of the price. Rockwell management looked at the sales ledgers. The amateur radio division, which had once been the cultural heartbeat of Arthur Collins's empire, was now a financial distraction. The company was generating hundreds of millions of dollars, outfitting commercial jetliners with flight directors, and supplying the military with encrypted communication networks. Building standalone radios for hobbyists was tying up highly paid American engineers and valuable factory floor space for a market that had already moved on. The corporate decision was absolute. Rockwell shut down the line. The KWM 380 was quietly discontinued. The American dealers cleared out. The hobbyist catalogs dropped it. The old assembly benches changed. Avionics contracts took over completely. The civilian dial went dark. The amateur era was over. The Collins radio brand did not vanish, but it migrated to a place where the listener could no longer follow. Today, the Collins name still exists, emblazoned on the communication panels, weather radar screens, and flight deck navigation computers of thousands of commercial jetliners and military aircraft worldwide. As a division of Collins Aerospace, it remains a pillar of American aviation technology. But the era of the hand-wired St. James Gray table radio is long gone. The factory in Cedar Rapids still stands, but it is now a sanitized, high-security campus dedicated to software-defined avionics and integrated flight systems. The local station studios and the vibrant American electronics shops that once sold Collins equipment have been replaced by high-security labs and data centers. Yet the original promise, the promise of absolute reception, has found an afterlife in a community that refuses to let the analog dial go dark. On any given weekend in the United States, you can find the ghost of the Collins empire living in the back corners of church halls and fire stations at local ham fests. Informal, sprawling swap meets where amateur radio operators trade gear, components, and memories. In the dusty, dim light of these gatherings, you will inevitably find a Collins S-line receiver or a KWM2 transceiver sitting on a folding table. It is almost always surrounded by a small crowd of operators who know exactly what that winged emblem represents. They aren't just looking at a piece of discarded military surplus. They are looking at a standard of mechanical precision that has arguably never been surpassed in the civilian world. This equipment remains the crown jewel of the American vintage radio preservation community. On eBay, specialized antique radio forums, and dedicated YouTube restoration channels, the demand for Collins gear remains intense. Former employees, retired military technicians, and passionate hobbyists spend hundreds of hours meticulously desoldering aged capacitors, realigning PTO units, and hunting for rare vacuum tubes to keep these machines transmitting. They do this not because it is the most efficient way to communicate. A cheap handheld radio or a smartphone app can do that with far less effort, but because the act of tuning a Collins radio is a tactile connection to a different era of American life. It is a connection to the days when American radio was not a subscription service or a digital stream, but a physical agreement between a signal, a machine, and a room. The surprise footnote to this history is that while the consumer electronics market abandoned the high-end analog radio, the very technology that Collins pioneered for the space program, the digital integration of signals, has become the foundation of our modern, hyper-connected world. Arthur Collins' disastrously expensive C system, the computer network that drove the company to bankruptcy in 1971, was essentially a premature vision of the networked world we now inhabit. The engineers who were mocked for building too much radio were simply living in the wrong decade. The collapse of Collins radio was not a failure of innovation, but a failure of timing. The company built the tools for a world that was still decades away from understanding why it needed them. When an enthusiast today finally gets a restored S-line receiver to fire up, they don't just see a piece of vintage electronics. They see the physical manifestation of an American philosophy that believed anything was possible if you were willing to build it with enough precision. The digital readout might be dark, the frequency display might be silent, and the local radio shop that once serviced the unit might be a parking lot. But when you flip the power switch, the vacuum tubes begin to glow, a soft, steady orange. The receiver clicks with that familiar mechanical authority, and for one more night, the signal comes through perfectly. See you in the next video.